And so we'll just say we've got carbon that has so many carbons, we don't know, we'll figure that out. Hydrogen, and then oxygen. So there's a compound that we don't know what the subscripts are, but we'll get to that point where we'll find them. Plus O2 would give you CO2 plus H2O. Alright, we don't have to balance it either. We're not going to do anything with balancing. So the oxygen, we can't figure out how much oxygen is in the original compound because there's oxygen being brought forth through the air. So we got oxygen from two sources. But what we can do is we can determine how much carbon was in the original based upon conservation of atoms. So we know the weight of this, CO2, the whole thing, the weight of CO2 is right here. So what we can do is what we did yesterday, is what we can do is figure out how many grams of carbon we have, right? If we have 10.38 grams of CO2, we can convert that 10.38 grams of CO2 with the molar masses of CO2 and oxygen, or CO2 and carbon, and then we can figure out how much carbon the original substance had. Yes?
How did we get 10.38 grams and 2.5 from 3.8 grams of the
Well, because we're not including the oxygen.
Oh, because that's the oxygen bringing in.
Right. We don't know how much is being brought in. We know it's burning. We know oxygen's coming in. We know it would be really easy if we knew the oxygen, because then we could go ahead and do that. But we don't. Okay? So, right, it looks like how in the heck can you have more than what you started with? That doesn't prove the law of conservation of mass, but we have a lot of oxygen coming in. Okay? So, we get back to this. We can figure out the grams of carbon, right? Okay? Now, over here, we can figure out the grams of hydrogen in the original. Okay? Because we can do the same thing with this amount of water being produced. Okay? So we can take that, the grams of H2O, we can find the grams of H's. And if I find those two, can I find this third one?
Yeah.
I can, because I know the mass of the original. This is the mass of the original. So if I find the mass of carbon, I find the mass of hydrogen, then I can take those two weights, add them together, and subtract it from 3.871, and then I'd have the grams of oxygen. Then if I have grams of carbon, hydrogen, oxygen, then I can go do my thing with my empirical formula. Okay? So I'm going to switch pages here, just because I don't have enough room. And then I can go back and forth. But I'm going to go ahead and set up how I can find carbon and hydrogen and oxygen. Okay, real quick. So if you get a problem like this, you'll be able to always figure out the mass of carbon in your original sample. You'll always be able to figure the mass of hydrogen in your original sample. If it's oxygen, at the end, we'll be able to determine that by taking the difference of those two. Okay? So let's go ahead and I'm going to show that. So the first thing I'll do is I'll do CO2. So I got 10.38 grams of CO2. So then I can go grams of CO2 to grams of carbon. And it is 44.01 grams to 12 grams is my ratio. Now I got grams of carbon. And we know that the source of that carbon was the original compound. So I go ahead and do that calculation, and I come up with 2.83 grams. Any questions on that? All right. Because I know for every 44 grams, I've got 12 grams of carbon. The next thing I can do is I can do hydrogen. So I got 2.568 grams of H2O. And for every 18 grams of H2O, I have 2 grams of hydrogen. And so I do my calculation, and the hydrogen I find out is 0.289 grams. Any questions at this point? Now later on I'll have to take those weights and I'll have to convert them into moles, but let's do oxygen. So oxygen is the missing amount. So if I take these two, and I know that oxygen, whatever that amount would be, added together is going to get me the 3.871 of the original compound. Then the difference between 2.83 plus 2.289 and 3.871 would give me oxygen. So how much oxygen is there? So what's the difference? What is it?
0.752.
Okay, 0.752. Everybody get that? You just take and subtract those two from 3. So that's how much oxygen I have. So at this point in time, I have to just go to moles, okay, of each one. So it's just like we did yesterday. So I'm going to finish this out, finding the empirical formula. So that's what you do to get all your weights, and then I'll do the rest of it. So then we have 2.83 grams of carbon, 12 grams of carbon, 1 mole of carbon. We got 0.289 grams of hydrogen, 1.01 grams of hydrogen to 1 mole of hydrogen. And then the last one would be my oxygen, and that's 0.752 grams of oxygen. 16 grams of oxygen to 1 mole of oxygen. So then I get these numbers generated. I get 0.236. And 236. Okay, next one. I got 0.289 moles of hydrogen. And then the last one would be my lowest amount, and I have 0.047. Well, that goes into itself once. So I get 1 oxygen. When I do this one, I get 6 hydrogens. And then when I do this one, I get 5 oxygen. So my formula would be C5H6O. So the last two problems are worked in that way. You've got to figure out your grams of hydrogen, grams of carbon. Then oxygen you can't do that way because you got oxygen coming from an external source that's causing combustion. You can do oxygen. So that's for the last two problems to do on the assignment. If you got to that point and weren't able to do those, that's the process you would go through to do it. Okay? So I told you I'd give you the rest of the time today for the most part to work on things and that. We'll have a lab where you're going to have to do some separation of a mixture, and you'll have to do a chemical process to do part of it, and then dissolving is part of it. So we'll talk to you about that tomorrow, and then we'll have our lab groups. Labs, this is what I'd like to do on labs. I would like us about every 2 labs to switch partners. So that we'll go 2 labs maybe with partners that you're wanting to go with, or doesn't. I think everybody's pretty much, it doesn't matter who you probably work with. And then we'll switch up about like every 2 labs and have you go with somebody else. Just kind of switch things up from time to time. Okay? And that way you get a good mixture of who to work with and who to do things with and that type of thing. So, any questions?